Geometry section 3-4. Start out with the theorem, the triangle angle sum theorem. This may be a theorem you already know. Probably in a previous class you've been taught that a triangle's angle sum is 180 degrees always. That's true. Officially now it's given to you in geometry. I do plan to prove this for you in class. I may have already done it by the time you've watched this video. If not, please remind me in class the next time you see me that we need to write this proof out. It's an important one. But it's true. And now we can use it now that it's a theorem. We prove it, it's a theorem, now it can be used in more proof writing, okay? And our book puts it this way: in any triangle ABC, the measure of angle A plus the measure of angle B plus the measure of angle C equals 180, right? Always. Doesn't matter how slim or weird you try to make that triangle. If it's a triangle, the angle sum is exactly 180 degrees. So let's look at this example. They should have said triangle with the symbol there. And you can see, you can read the directions if you want to, but just take a look here and you'll see that they're trying to find A, B, and C. And the first one that jumps out to me is actually C. Since this is a 90-degree angle here and this much is 70, we would know that C is 20 degrees, okay? The second one that jumps out at me would be B, because if I look at not the whole triangle, but just this much, this kind of medium-sized triangle, you've got a 70-degree angle, a 90-degree angle, and B. So again, B is 20 degrees. Just like C, B is 20 degrees. A, I can take two approaches, I would think. If I look at the small triangle here, knowing that C is 20, you would also know that this is 90 degrees too. A is going to have to be 70 degrees. Or, just to confirm, if we looked at the large triangle, right, you've got a 90-degree angle here. We've already determined that this is 20. In each case, I'm using the triangle angle sum theorem, and I kind of found them in backwards alphabetical order. Okay? Then there's the idea of classifying triangles as different adjectives. Equiangular means equal measure. So a triangle that is equiangular would have three angles that are all the same measure. Equiangular, all right? Now, if you put the two things together, you could probably glean what that angle measure would be, right? If the triangle angle sum theorem says that they got to be to 180, and we've got three angles that are all congruent, they're all going to have to be 60. So that's really what equiangular means when it refers to a triangle. It means something slightly different when we refer to polygons of more than three sides, right? So for example, a quadrilateral that's equiangular would have angles that are all 90 degrees. And we'll talk about that later. But for right now, know the triangle one. Acute means something that's between 0 and 90. I like to show that using the inequality like this, right? A standing for the angle measure. A right angle is when the angle is 90 degrees exactly. And an obtuse angle is when it's between 90 and 180. Okay? And there is something called a straight angle as well. Straight would be exactly 180 degrees. We've talked about that before. There's something called a zero angle as well. But really the important three words are those three: acute, right, and obtuse. How do you remember that? Well, students have told me that they remember a cute little angle. That's how they know the difference between acute and obtuse. Use it if you want to. Those four words speak of angles. The next three words speak of side lengths. Equilateral, again, equa, the prefix there meaning equal, and then lateral referring to the sides. Equilateral triangle would have three sides that are all the same measure. An isosceles triangle, you probably know, is a triangle that has at least two sides congruent. Now, key word, at least. An isosceles triangle has at least two sides congruent. It can have all three sides. So what I'm saying is an equilateral triangle is also, in fact, isosceles because of the word at least in that definition. And then scalene is when they're all a different length. So three the same, at least two the same, all different. And then back here, imagine showing all that work for those simple problems that we already did. Unbelievable. It says classify the triangle by its sides and its angles. So use two words there. And I'll pause the video if you don't want me to say it too quickly. But this again, two words. This would be an, I want to use which word first. This would be an obtuse scalene triangle. Obtuse because that angle is clearly more than 90 degrees. Now, I'm not crazy about the kind of picture that, or the kind of problem that says, what does it look like? But this is obvious, right? That's an obtuse angle. So it's an obtuse triangle because it has an obtuse angle. Obviously, it can't have more than one obtuse angle. But it's also scalene because all the sides are of different measure, right? So obtuse, scalene. If it had no obtuse angles and they were all acute, then it would be an acute triangle. And speaking of that, let me go back and just clarify one thing. I should just say a little bit more. These are speaking of the angles themselves. When we classify a triangle, all of the angles, all three angles, would have to be between 0 and 90. When we're talking right or obtuse, just one angle. I'm sorry I didn't mention that earlier. You probably got it anyway, but I should have mentioned that. So if it has an obtuse angle, one obtuse angle, it's an obtuse triangle. Obviously, it can't have two because that'd be more than 180 just for the two angles. If it has a right angle, you've seen plenty of right triangles before. There's only going to be one right angle. The other two angles are going to be acute. Glad I could clarify that. Okay, so we said this one, obtuse, scalene. And then finally, taking a look at this triangle here, if you extend aside, this angle that is formed is what's known as an exterior angle. Now, I've drawn it in such a way that I'm speaking of this vertex, okay? The other two angles are what are known as remote interior angles. Think about what a remote is. You have a remote control in your house. It's remote because you can move around with it, right? You can toss it over to your sibling or whatever. That's a remote. These are remote because I chose this vertex, therefore the remote interior angles are the other two. Had I chosen a different vertex, the remote interior angles could move, okay? So with that, don't you know that these two angles would add up to 180? They form a straight angle. Don't you now know, because of the triangle angle sum theorem, that these three angles add up to 180? So with a little bit of subtraction, what you could do is prove that the exterior angle is equal to the sum of the two remote interior angles. That leads us to our final theorem for this lesson. Triangle exterior angle theorem says that an exterior angle of a triangle has the measure of the sum of its remote interior angles. So let's take a look here. And they want us to find the measure of angle 1. What I'll have a lot of times here is if I take a volunteering class, the student will say, well, this here is 55, and then 55 and 90. You don't really need to do, you can do that. You can get the right answer that way, but we did just make a theorem, okay? So if this angle out here, which is an exterior angle, is 125, and 90 and the measure of angle 1 have to add up to that 125, then this must be 35 degrees. The measure of angle 1 is 35 degrees because 35 and 90 add up to 125. Really, when a student does that, they're using the logic of how you prove the exterior angle theorem. There's no need to do that if you understand the theorem. One last thing, by the way, there are two exterior angles at any vertex. If I had extended this way, this angle would have been an exterior angle also. Notice that they're vertical with each other, so they're congruent. Therefore, just kind of in closing, if I asked you to draw a triangle with exterior angles at each place, you just want to extend in one way, right? One direction, not both. This is an exterior angle, this is an exterior angle, and so is this. Okay, thanks for watching.